national anthem, followed by our President to introduce the meeting. Handing over to, I think it is Brenda today, Brenda Rudolph, to introduce our speaker today. Then the illustrious David T. Chapman will enlighten us with the latest weather. And then at the end, for those of you who would like to, we just split up in smaller groups and just chat about the weather or whatever else we can think. All right, with that, let's go for
not much on that. Yeah.
Anthem. But before I do, let me allow you to mute everybody. So if you want to speak forward, you need to unmute yourself again.
Yes, there.
Very nice. Thank you,
Caroline.
Yes. Hello, everyone, and welcome to our May Zoom meeting. I can't believe that it's the end of May already. And weather always seems to be a topic of conversation, doesn't it? As we Ontarians, when April and May arrive, we always think, oh my, spring is here and the flowers are going to bloom. And all of a sudden, we get those winter days again, and it's so discouraging. But today, of course, we got another hint of summer, and hopefully the rest of May will bring us those warm spring days, and then we get into summer. So hopefully our speaker today will talk a little bit about Ontario weather and why we get so many changes. And I'm going to pass this on to Brenda Rudolph right now. Thank you and enjoy.
Good afternoon, everyone. It's my pleasure to welcome our speaker this afternoon, David Chapman. David started photography and storm chasing at the age of 16. He is a self-taught artist of photography who enjoys photographing and videoing the unusual in weather phenomena, scenery, and nature throughout Ontario. David's work has been sold to clients around the world. David shares his love of nature through educational, entertaining presentations of his photography and knowledge gained through his experiences and studies of meteorology, ornithology, and the Northern Lights. He offers many different presentations from storm chasing to the seasons of Ontario to birds of Ontario. And today we are fortunate to have David lead us through wild, weird, and wacky weather. David Chapman.
Thank you very much, Brenda, for the fantastic introduction. It is great to be home again, even if it has to be virtual. It is great to be back. I grew up in Markdale, and a lot of my photography was done very early on in the Beaver Valley to Markdale up towards Meaford. So I really feel like I'm back at home again when I'm presenting today, which will be great for the program because I'll be able to use a lot of local landmarks to kind of talk about where you might be able to see something like this as well too. So I'm really looking forward to today's program. And just to kind of expand on what Caroline said there about the, how we get into April and May, and then all of a sudden it's May 5th or 6th, for example, last year, and it's snowing, and you're like, oh, I thought this was a couple months ago. So it just seems that these upper level lows come in from kind of get stuck over James Bay and Hudson Bay, and then that allows them to push the cold air down south into southern Ontario, and that's why sometimes in May, winter just tries to hold on a little bit longer. Today's program will have some of the wild stuff in it. It will also have some of the stuff that you can enjoy when you're out hiking, walking, or gardening. There's a lot of weather that I actually spot when I'm out just gardening in my backyard. It's some little neat things that you can see without actually having to go very far to experience it. So, and also just like to thank everyone for having me here today. Brenda has been fantastic to work with, and I've actually had the pleasure of working with Martin before as well too. So they have taken really good care of me, and I knew everything that was going to be going on today. So thank you to them, as well as thank you to everyone at the Beaver Valley Provost Club. So without further ado, I shall get this show going. And if you do run into any trouble with bandwidth issues, I don't usually have any problems with it, but if you do, one thing you can do is just turn your camera off. That sometimes helps save your bandwidth as well a little bit, but generally I don't have any issues that way. All right, so, and share screen. I will be doing a lecture part of this and then a little bonus clip at the end where it's about 1 minute and 55 seconds of sound, and I go quiet and just let you listen to that, as well as I get a drink of water at that point too. And so, yeah, my dad and I, we started storm chasing in 2000. We lived in Markdale at the time. And basically how we started was by using AM radio to zero in on storms if we had to travel a distance. So if it was crackling more in Barrie than London, we knew to go such and such direction, basically, especially if we were out on the road at that point. And eventually in 2010, we got portable internet. That allowed us to basically see the storms as we were traveling, made a big difference. And now I can do all the storm chasing from the palm of my hand. One more side note, I probably was storm chasing before 2000. So before the age of 16, basically it was, is there a Tim Hortons that direction and a storm? So we basically go and try to get both of them, especially towards the Meaford direction as well. So first thing we're going to cover here is shelf clouds and gust fronts. So generally they are the leading edge of the thunderstorms, right where the warm, moist air is out in front, and then the cold, sinking air that's coming down with the rain in the actual storm itself, and sometimes even has hail with it. So one of the last big fronts to actually go through your area was, I think it was October 24th or 23rd last year, and it actually produced a small tornado in the Thornbury area towards, and then out over Georgian Bay. So that was actually along the front side. Typically tornadoes form on the backside, but they actually sometimes can get twisted up on the front as well too. But here we're going to look at the basic gust front here, and it's actually tied to a microburst, as you'll see once the visibility gets reduced. So first thing we have is the leading edge of the winds and the rain. You can usually tell that from trees either getting blown, a little bit of dust, or in this case, the heavy rain starting to begin at this point. But the wind speeds at this point are probably around 40 to 60 kilometers an hour, just gauging it on that vehicle. But then they get up to around 100 kilometers an hour, and you'll see how it reduces the visibility. I want you to watch that silo in the background there. And you can really see it whipping past here. It almost reminds me of a whiteout, only it's in the spring instead. So a little bit more contrast with the greens of the field growing, but you can still see visibility was quite reduced there. Something else that we get to experience in the Great Lakes, especially Lake Superior, Georgian Bay, and Lake Ontario, is something called snow spouts. So you can probably notice there's a bit of snow on the ground there, but we actually have a funnel cloud in the background. So I've seen photos of this over Wasaga Beach area on Georgian Bay, and I'm sure they were seen from Collingwood that day as well too, and maybe even Thornbury. So it is something you can see in the area, but you can see it was just a small little funnel in the background. Generally, they are smaller during the winter, because of the fact that there's less moisture to work with. So that means that your snow spouts or your snow funnel clouds are generally a lot smaller and tend to be more thin as well. So in this case, what is causing this is you have a 13-degree temperature difference or greater in Celsius than the water and the 850 millibar level, which is the same as 5,000 feet up and 1,500 meters up. So when you get that 13-degree temperature difference, what happens is you start to get more thermals rising off the water. And then if you have converging winds over the lake, or in this case, Georgian Bay, you would then have it converging on a zone. And what happens is clouds start to tower upwards. And as they tower upwards, what happens is these thermals get caught underneath them, and they get stretched out because the cloud's going up higher and then the thermal's connected to the cloud, and it just stretches it out. I want you to think about it a lot like a figure skater. When they speed up, they pull their arms in, and that causes them to go faster in that. So that is technically how these thermals work, and then eventually turn into snow spouts or water spouts. Traditionally, we see more water spouts than we do snow spouts, but both are possible over our Great Lakes. So here, for example, there's always a joke that whenever there's a storm in the area, Buffalo gets hit. No different on this day, really. But here's your convergence line here. You're not seeing the top of it, but you can see how low to the surface it is here. And then basically you have a thermal that develops right in the center of your screen, just along the water there. You can see the spray ring. So the spray ring, after the thermal forms, the spray ring is the first thing that you see. Then what happens is you start to get a condensation funnel above. So you can actually see that here. We have a condensation funnel. And just because it's not completely connected to the surface does not mean that it's not a fully mature water spout. It is a fully mature water spout, even though it's not connected. And these are actually called fair weather water spouts. Now, if you're on a boat underneath it right now, 80 to 140 kilometer winds, not exactly fair weather. And sometimes they do even come inland as well. So most of the time with these types of water spouts, they only go inland maybe 200 meters to a kilometer at most before they dissipate, because their energy is coming right off the water. Plus there's less friction with the water as well too. Now, as for lake effect, I don't know if I should really be telling anyone here how lake effect forms, because I'm pretty sure everyone here could tell me with the experience. When I lived in Markdale, I know lake effect was a very common thing we dealt with in the winter, but I will go through it. And that's basically the fact that, again, you get that 13-degree temperature difference over the lake. It creates an instability, and that with that 850 millibar level or 5,000 foot level. And when you get that, then the clouds start to tower upwards. And then when they start to push inland, they actually slow down because of the friction of the land as well too. So then the cloud over the lake starts piling into the back of it. The snow keeps getting heavier and heavier. And eventually you can have, snowfall rates of 30 centimeters every 6 hours. So it can be quite impressive, as anyone living in Grey and Bruce County will tell you. It can be very impressive and neat in how localized it can be as well too. You can be clear, for example, let's say you're clear in Meaford, and then you're getting snow in the Beaver Valley and Markdale, and it's just been continuous all day. So that's just something that lake effect can do, and you can just be so isolated when it is. And when you're underneath it, some of the neat things with it is the fact that sometimes the winds can be completely calm, because again, they're converging. So you may have winds before the squall and then after the squall, but underneath it, you can just be getting piles and piles of snow, but with very little wind. In this particular case, so this is a snow squall event that formed on the front of a cold front. And so it's not lake effect, it's actually driven by temperature difference, where let's say it got up to 2 degrees Celsius that day, and then the cold front comes through and knocked the temperature down to -15, -20, -25, which created very strong winds, but also can even cause snow squalls to have lightning in them on the rare occasion. The Great Lakes is actually one of the best locations in all of North America to potentially see lightning in the winter while it's snowing. Maybe you have even seen it before as well too. So the technical term is what they call thunder snow. And the Great Lakes, like I said, are one of the best areas for that type of thing. Fortunately, with cold front snow squall systems, they tend to push overhead and then clear on out, and then you have a nice, beautiful evening. Now we're going to take a look at something I've seen on Georgian Bay as well as Lake Ontario and Lake Erie, and that is this ice bridge. So what has happened, I'm sure you've been to the Georgian Bay or one of the Great Lakes shorelines, and you see these ice mounds that form on the sides of them. And what can happen is you have layers of ice that start to form on the lake as the winter goes on, but the windstorms kind of crunch it all up again and then throw it up into a pile on the shoreline. Well, eventually you might get a stronger windstorm that comes in. And as it does, it might cut out some of that mound and make it into an ice cave. Or if the winds and the waves are strong enough, it actually will go right through the back of the mound. And that is when you get that ice bridge, basically, where it's went right through the back of it, giving you that overhang. And you can see here when the sun gets inside of them, it can actually melt it faster because of the sand and the rocks and other grit that is in there as well, too. So when you're looking at the structure, it's definitely a bridge that I would not cross. And it was actually one that I didn't feel all that comfortable underneath it as well, too. So I was basically in there, did my documentation, and then I got out of there after that point. Now, as for Arctic sea smoke, the very first time that I saw this, I was in Meaford. We went from Meaford, my dad and I went from Meaford to Thornbury. And basically, again, it's a very dramatic temperature difference between the water and the air. Only this time, it doesn't matter about the 850 millibar level. It is actually just the distance of basically the water and then the very cold air above it. So basically not, a centimeter or two, and then it's basically condensing. So in this particular case, it was about minus 22 degrees at the time, Celsius, and then 1 degree Celsius water. So as soon as that warm, moist air coming off the water hits that extreme cold air, it basically condenses into what looks like a fog or a super cool water vapor, and then continues to rise over the lake until it dissipates in the air. You can see it here at sunrise. So on Georgian Bay, you technically need it to be a little bit colder yet. I found when I was there, actually it was minus 25 when I saw it on Georgian Bay. And so again, Georgian Bay is a little bit cooler, but if you have that sharp cold air mass over the area, then it can lead to beautiful sights like this. I am happy to say, though, that it doesn't have to be winter for you to enjoy Arctic sea smoke. It can actually be late summer and even the fall, or any time that you've been on a river canoeing or walking along a river's edge. It can be the same thing. Basically, let's say the water temperature is 24 degrees Celsius, and then you have an unseasonably cool night of maybe 6 degrees Celsius. That can be enough to create that Arctic sea smoke, even though it's not as cold. So it's still a way to enjoy it. Maybe you have a pond in your backyard or a lake or something like that, and you've woke up in the morning and there's a fog over it. It's basically the same effect. So here's an example of it in the fall here. And sometimes what you can get with these is little steam devils that form. So they kind of look like miniature tornadoes. So you can kind of see them off to the left side of the screen here twisting. You'll see a better example of it here in a moment as well too. I've seen these on ponds before, but they really look like just small little tornadoes over the water, and they'll just kind of sit there. And they move a little bit with the winds. Generally, when you have Arctic sea smoke, there's not a very strong surface wind with it as well, too. So you can see that here. This is up in Holland Center area near Walters Falls. So you can really kind of see that kind of little vortice there. But again, yeah, it's in the winter, but there's open water to the minus 20 degree temperature, and there you have it. And Niagara Falls during the winter, I'm sure many of you, if not all of you, have been to Niagara Falls at some point, but if you ever have a chance to time it for a Arctic cold snap, and that it is beautiful at that point. Fortunately, you do have falls like Eugenia Falls and others that do actually generally keep flowing, and they can lead to the same beauty as well too. Hoggs Falls is another, and then Inglis Falls up in Owen Sound. So you don't necessarily have to go to Niagara Falls to enjoy that same type of thing where the whole river has kind of this Arctic sea smoke coming off it. And then, of course, at that time of year, even the mist coming off the smaller falls compared to Niagara Falls is still very beautiful as well, too. But one of the neat things about that time of year is the fact that the water, because the air is so cold at that time of year, the mist can hang in the air longer. So that can happen at Niagara Falls as well as some of those, even some of the smaller falls. Not as dramatic as Niagara Falls, but still gives you a really nice sharp view as well. Now, I promise I will be warming things up here shortly, just a little bit more winter before we do get into the nicer aspects that we're all looking forward to over the next section of the year. And so, for example, frost can give you some really neat optics. And here's an example here of a frost bow, or almost like a sundog bow, but you can see the kind of little sparkles on the surface there. And that's generally when the sun is about 3 to 8 degrees above the horizon. And here's an example of it on snow. So ice crystals on top of the snow, the sun's coming up and it's refracting off the ground like you're seeing it there. So I've seen this in Markdale. I've actually seen it right down in the Beaver Valley as well. This photo was taken just east of Markdale. So it does give you an idea that that can happen as well too. And then of course, along rivers' edges, you have more of a, generally have more frost because of the fact in the fall, the river is milder than the air around it. So it creates a bit more moisture that then goes over the vegetation, giving you that really nice silvery look. I've seen that down right in the Beaver Valley, right along the Beaver River before as well too. Elevation can make a big difference as well. One of the neat things is I usually use examples of the Beaver Valley to show that type of thing as well. But here, this is the Niagara Escarpment. I'm about 100 feet up the escarpment. Well, I went up another 100 feet up the escarpment. You can see the snow in the trees on the middle part there, but at the top, it changed the weather quite dramatically here. You can actually see that overnight, there was super cooled water vapor or a fog in the air, and it coated the trees in all this beautiful, frosty kind of wintry wonderland. So how did this form? I first learned this when I lived in Markdale. And generally what happens is if you have a snowpack already, and it's generally lighter, fluffier, what can happen is if you have a day of sunshine and the temperature may have got up from, maybe -2 to +3, for example. And what happens is the sun beating on that all day with very little wind causes moisture to evaporate off the snow. And as it does, it kind of creates a boundary with very little wind kind of pushing it away. It creates this area of heavier humidity. Well, as it gets colder that night, so let's say it drops down to -10 or -15, that moisture condenses more and turns into a super cooled water vapor. And every object that it goes over, it basically continuously coats it into this kind of beautiful wintry silvery wonderland. These are a couple photos from my house in Markdale, so you could actually see some frost patterns on the windows too. I'm sure generally every winter I would see that when I lived in Markdale. Here's an example of Arctic sea smoke coming off the river itself, and what it can do is actually cause something to form that's called rime. So you can see just how packed that is together. It really seems to be tighter than the typical hoarfrost. Hoarfrost tends to be more flaky. So for example, where you usually see rime is along rivers' edges and say lake edges, but when you typically see it is actually mountains will have a lot of it because clouds will go into the side of the mountains and just keep coating it and coating it and coating it. And you can actually have it be up to 5, 10, even sometimes 15 centimeters in length of this kind of rimey substance. This here is just on the edge of the Beaver Valley. I always enjoyed the differences between the weather at the bottom of the valley as well as the top of the weather or top of the valley. And one of the things that I always found really neat was the fact that I could be at the top of the valley, if it kind of one of those early season snowfalls where you're at the top of the valley and the snow is sticking, and then you drive down Bowles Hill, or if you really want to go wild, the one next to Talisman there, kind of the off-road, the no winter maintenance one. And as you went down, it would transition from basically a snow to nothing. You could be at the bottom of the valley and there'd be no snow at the bottom of it. So really neat to see how elevation can change temperature and the characteristics in the weather. Now, as for sundogs, typically sundogs are at your anywhere from 18 to 25 to 35,000 feet, but this was taken in Markdale. And you can see the sundog is between me and the trees at that point. It was actually minus 33 that night. So it was, when that morning came around, a lot of ice, a lot of frost, kind of ice crystal in the air, which gave you the sundogs right at the surface. Then there's lake effect sundogs, which I've seen from the Beaver Valley as well as towards Lake Huron, that type of thing. And it's generally from about the surface right on up to around 12,000 feet. And so that's generally where you get those. You get sundogs with the Arctic sea smoke off rivers as well too. You can see that here. This is a photo from Markdale, just where I, right up in front of my street there. And you can see kind of the sundogs on both sides. This is more of the typical level you would see them, which is around anywhere from 25 to 35,000 feet, especially in the summer. That's generally when they're higher up in the atmosphere, whereas in the winter, the regular sundogs tend to be a little bit lower because the colder air, the moisture is lower in the atmosphere. So here's an example of some of the clouds that can form on. This is actually a full solar halo, so a ring around the sun, but you can even get that with the moon. I used to love seeing that from Grey County, seeing the full halo around the moon. So you can see here's the ring, and then you can actually see some of the sundogs off to the side. I like to look at it when it's a full moon or three-quarter moon, because of course you can't stare directly at the sun, but you can enjoy staring directly at the moon. But of course, once the cloud starts to get heavier, it starts to obstruct the halo that you get to see too. Sun pillars, I saw my first ones ever when I lived in Grey County, and basically they're ice crystals. When the sun's a degree above the horizon or below the horizon, it'll cast up a kind of a beam. There's a picture actually in the Beaver Valley there with the fog below. I'm actually going to try to go back here, and that went back a little bit far. But yeah, basically they form in the ice crystals, and you just get the refraction of what color the sunset is or sunrise. You can get them at both times of day and that too. So this is actually from Talisman Lookout, and you can see there's a bit of a pillar above, the fog below, and then part of the valley there. So that was the first time I ever actually got to see the valley fog in as well too, and had a sun pillar at the same time. They actually will form around the moon as well too. This is a lunar pillar, so same type of thing. And what's really neat is when they form down to the town lights. So you're going to actually get to see that here. So this is ice crystal, horizontal ice crystal that's fallen right down to the surface. And every light, and there's Talisman, for example, you can see the columns and the beams. You may have been driving down the road before and actually seen columns coming up from vehicles as well. A little bit harder to see because they're directly with the car. But that's, for example, this light in the center there, that's the crosswalk in Markdale. And at the time, this was 2005, that was the new gas station on the north end of town as well too. So really neat to see that aspect. And during the 2013 winter ice storm or Christmas ice storm, I came up to the Markdale area. You can see the ice in the trees and then the pillars with the Chapman's factory there as well too. So you can see the plumes in this time lapse pushing through more and more as it was heavier. Sometimes you can still see the stars above it, but there was so much ice crystal in the air that day that you couldn't see the stars above it. So it really gives you some close to home light pillars for you to see, and keep an eye out for next winter as well too. Now, as I promised, I would warm things up here. And so crepuscular rays, one of the things I love doing is walking through the woods after a rain the night before and the sun comes out. Generally what happens is enough moisture rises up that any sun shining through really gives you these beautiful crepuscular rays. But you can even get it in the country when you're walking on a kind of misty, foggy morning and you look towards the sun, you can see the fog shining, or the sunlight shining through the fog. And if there's enough trees there, it can give you some really nice contrast as well too. And here, for example, is kind of the time lapse aspect. This is 10 minutes condensed into 10 seconds, so you can see how it almost disappeared and then got stronger again as well too. And here we are taking a look at fog. This is something I've seen at Georgian Bay before as well too when I was younger, and that's something that's called a fog bow. And the reason why they don't have color to them is because of the fact that they are much smaller water droplets compared to raindrops. So they don't refract and scatter the light the same way. They basically just keep a white tone to them, although sometimes you can get little hints of red and blue with them. And there can be double fog bows as well. Once the fog gets too heavy, though, you don't really have any chance of the sun getting through. So how does fog actually form? Well, typically what you have is you have a temperature of, let's say, 10 degrees Celsius, and then the dew point matches the temperature, so it would be 10 degrees Celsius, and that's generally saturates the air mass, so about 100% humidity, and then you get your the fog that way. And one of the things I enjoyed and first learned about this was in the Beaver Valley, and that was the fact of being above the cloud, or at least parallel with the cloud, or in this case, the fog. And so what's neat about it is the southwest winds would catch the top of the fog. Now, they weren't very strong. This is sped up so you can see it, but it was really neat to kind of be parallel with the fog. But that wasn't the only reason that I was there that day, actually. The reason I was there is I saw a little bit of clearing on satellite. So I wanted to see if I could capture something that's called a glory. And typically you would have to be from an airplane or a mountaintop to see this with a cloud deck below you. But what you're going to see here pop up in the center of your screen is kind of looks like a colorful circle. And you're seeing it just coming to view now. And it kind of looks like a circular rainbow. And what's really neat about it is you can actually walk back and forth and it will follow along with you. But this is something that I do believe you could see in the valley. You'd have to be the tallest thing. That would be the tricky part, as well as have the fog below you. So it would take a lot of timing, but I can at least show you that it is possible, because this is from the Niagara Escarpment as well too, only from the southern end of it down in the Niagara region. So again, you can see the fog there. So that's something that you can see. You can see it from a passenger's window in an aircraft, but generally you can actually even see it from more so mountaintops, but even smaller escarpments as well too. And roll clouds, this is actually taken in the winter. Typically, we see them in the spring and summer and maybe early fall as well too, but sometimes we do get them in the winter as well. I've seen them in the Stayner area, and the first ever roll cloud that I experienced was in between Goring and Markdale. So that does give you an idea that they can be quite local as well too. And that's it there, actually dissipated. Took only about 20 minutes to dissipate, but here's a few photos that I took just to prove that it was winter at the time, because we were going through a January thaw at the time, and you can see it going overhead. But the next view is probably my favorite angle of it, because of the fact that blue sky and then the sun hitting the front of it as it rolled overhead. And so, like I said, it's something that we can experience in your area as well as mine. And here's an example of the typical time of year. So this is the summer. We had a thunderstorm over Lake Ontario. It outflowed, so it gusted out, and then the roll cloud separated from the storm. And one of the neat things is on the back side of it, the air is sinking, whereas on the front side of it, the air is actually rising. And you'll get to see that whole process in the next clip after this one. So the clip that I'm showing you next is the Welland Canal. And you can see here's your thunderstorm, and here's your kind of roll cloud or rolling gust front. So the storm is actually still trying to pull in warm, moist air, but this rolling gust front is actually a pocket of cold rolling air, and it's pushing away from the storm. And basically what it's doing is shutting off the warm, moist air that's going into that storm. So eventually the storm decays and the roll cloud pushes on. The roll cloud can become another storm. It can actually cause another storm to form, or if the temperature becomes too equal behind it as well as in front of it, it will also dissipate as well. So this is what's left of that about, again, 15 to 20 minutes later, where the cloud really doesn't have much of a feature to it anymore. It just kind of looks like almost like an overcast day at that point. Something else that I've seen when I lived in Markdale, as well as across parts of Ontario, is something called fall streak holes. And this is something to look for when you have kind of this mackerel sky, where it's kind of a mix of alto stratus, alto cumulus. What'll happen is you'll get these kind of like hole cut features in it. So they're called hole punch clouds, fall streak holes. This is another name for them. And you can kind of see that there, where everything looks to be kind of falling away from it in the center. And really, that's actually what's happening, is the fact that the cloud is super cooled water vapor, but if enough ice nuclei forms, it creates a dominoes effect. And as that effect takes hold, it starts to fall away from the cloud deck and goes into kind of this wispy look, where it kind of looks like cirrus cloud, where it's kind of wispy and falling away from it. They can be quite small, as you're seeing here, or they can actually be quite large as well too. So we'll first look at the process here, and you can see the process where the cloud is basically kind of falling away. There's your cloud deck above, and then your cloud deck where the sun is as well too. And then this is falling away. So that's where the ice nuclei has taken hold and kind of that created that dominoes effect of the cloud falling away. So that's the process. Now we'll take a look at a couple examples. Sometimes the cloud deck dissipates and all you have is the ice nuclei, the cirrus cloud that's wispy there. But here's an example of one that's not in the shape of a hole or a circle, but more of a boat. But you can see kind of that falling away process. It has a different texture to it compared to the cloud deck. One of my favorite examples of fall streak holes actually was at nighttime, and you can see that here where a couple circles, couple fall streak holes in the sky, and they actually have been called in before as UFOs. And I guess when you look at it, especially at night, you can kind of understand at least with the circular shape on how someone could call it in for that reason. And northern lights. Well, I have seen probably from the Beaver Valley, Markdale, Durham direction, I've probably seen about 150 to 175 displays of northern lights when I lived in the area. And so I will be sharing a couple websites with you as well. How they typically form is you have a solar cycle, and every 11 years, you have a maximum number of sunspots on the sun. And they produce solar flares / coronal mass ejections. And as they do, what happens is you have a better opportunity of that being Earth directed. A lot of them miss the Earth, but then there's some that come towards Earth. And then that interacts with our interplanetary magnetic field, so IMF. And as it does, that's what, if the IMF tilts south, it lets that energy actually into the atmosphere. I'm going to actually stop this for a second because this was taken in Markdale, or just north of Markdale, a couple concessions, so really local as well. But as it does let that energy into the upper part of our atmosphere, it excites the nitrogen atoms as well as the oxygen atoms. So when it does that, then that's when you get the colors. So nitrogen atoms are red and the oxygen atoms are your green. And so you can kind of see that taking place there as well too. And they do actually happen in, right into the southern US. They've even been seen in Mexico before, extremely rare, but this is south of Toronto and you can actually see the northern lights. There's dawn there as well. And then the city lights of Toronto there too. So you can see that. And when you have streaks and rays like that, that's called a substorm. So most of the time it'll kind of sit there as a dull arc to the north, but when it breaks into a substorm, like what you're about to see, that is when it's truly spectacular to the eyes. And I've only ever seen two halos, two arcs to the north, not break into a substorm. So generally it will treat you at some point if it hasn't already produced one earlier. Now, something you can see from the garden is shear funnels. So these are little funnel clouds that'll form on those days where you have a mix of sun and cloud. And when you have that sun and cloud, it just adds enough instability in the air to form these little funnel clouds. Sometimes the clouds above are not that big, but you can see the funnel here. So a lot of times the clouds can be dissipating, and that's when these funnel clouds will actually either form or become visible because the actual cloud itself is completely dissipated. So we're going to take a look at an example of the process here. So we have a larger cloud above, but we have these other clouds that are kind of dissipating, and I will speed up the film so you can see that aspect. It's kind of in the shape of a mustache at that point. So again, these are all just from my backyard, and the Great Lakes during the summer, you always have a good chance, especially when this cloud is first starting to develop as well. It develops and then dissipates. That's generally when you'll get the best opportunity. So like I said, when you're gardening, it's a chance to just kind of occasionally look up and go, oh, wow, there's a little kind of funnel cloud that is formed. And they generally last anywhere from 30 seconds to 3 minutes in length. So not very long lived, but neat to see the mechanics without having to worry about it coming down to the ground. And even if you don't see a funnel cloud, there's often clouds, especially days where it's a little bit windier and you have the lower cumulus clouds, you can get some really neat twisting action in that as well, where you can really see it with your eyes. This is sped up, but even with your eyes, you'd be able to see the twisting action and the motion taking place, especially the closer you get to Georgian Bay, because the land breeze interacts with the bay breeze. And this is the time not to be gardening. This is your supercell tornado. And about 10% of all supercells create tornadoes. So what is a supercell? It is a rotating thunderstorm. So it just, whenever a storm is already rotating, it has a much better chance of potentially producing a funnel cloud or even a tornado. And even though it's only 10% of supercells that form tornadoes, 90% of all supercells generally have some form of damaging winds or hail or microburst that takes place with them at some point. So it is, regardless, supercell storms are the monsters of generally all thunderstorms. Then there's rainbows. So I remember seeing a lot of rainbows from Grey County when I lived there, especially in the fall. Spring was pretty good too, but the fall I found to be the best. Sometimes you have drought years, so you have to get creative and use an irrigation hose to get your rainbow or hose bow. And then in this case here, you can see these little waves coming in, kicking up water, and you just see a bit of coloration in the center of the screen there. And so that's a wave spray bow. And so that's something you can see if you're, going up to Georgian Bay or something like that. And you're just at the right angle, the sun's overhead, you can get those wave spray bows. Typically, though, for rainbows to be seen, you need your shower. Let's use the evening, for example. It's moving west to east at the time, and then it clears behind. And when the sunlight hits that, it refracts the light, scatters it, and gives you your rainbow colors. But you don't always have to be on the same side as the sun. This is on the east side in the evening, looking towards the shower. You're not going to get the rainbow this way, but you can get tremendously beautiful rain curtains. You can see that here with the pinks and the orange hues as well. So regardless of if it's a narrow shower, either side of that shower, it could be quite beautiful regardless of which side you're on. This is towards Shelburne, so you can see this storm off in the distance had a little bit of a rainbow at the bottom there. So generally earlier in the day, your rainbows are going to be a lot smaller. And when the sun reaches the horizon, that's when it's going to be the highest. That's when your rainbows are the largest. So here's an example of I think this is around 3:30 in the afternoon. You can see how low the rainbow is to the horizon, but notice how it's getting higher with this time lapse. So over a 12-minute period of time, you would actually see the sun's getting lower and the rainbow's getting larger. And like I said earlier, when the sun's right on the horizon, that's generally when you get the largest rainbows if the shower's in the right direction. And November gales. So when it comes to November gales, they are generally guaranteed every year. It seems like each fall we get a big windstorm in the Great Lakes. So why is that? Well, that's because of the fact that we often have these Colorado lows that come up, and they're pulling in warm, moist air from the south, from the Gulf, and then they're pulling cold air behind them from the mountains, the prairies, and even the Arctic. And as they push up towards the Great Lakes, and let's say Wisconsin, they're still continuing to deepen, and they seem to reach their full maturity right over Lake Superior, Georgian Bay, and that's when the low pressure center is at its deepest pressure. And when that happens, that is when you get these big wind events across southern Ontario. So generally every fall. So like, for example, the fall windstorm we had last year, November 15th, we had winds clocked in southern Ontario at 141 kilometers an hour in St. Catharines. And where I was positioned on Lake Erie near Port Colborne, we had winds of 131 kilometers an hour. So pretty impressive considering there was actually no storm with them at that point. So that is quite fascinating in that regard. So I found when I lived in the Markdale area that Georgian Bay, it was winds that came out of the north or northeast that gave the biggest waves, and that as well when I was there. Now, lightning. Lightning is, we're taking a look at the classic cloud to ground lightning, and there's also what's called bolt from the blue lightning. So this is lightning leaving the entire thunderstorm and going outside of the range of it. So sometimes lightning can hit 5, 10, 15, even 20 kilometers away from the storm, which is why they say wait 30 minutes before going back outside after you've heard the last rumble of thunder, because the fact that it can reach so far away, and make sure there's no new ones forming as well too. And you can see cloud to air lightning here. So this is your weakest form of lightning, and the negative charge is in the cloud, and then the positive charge is in the air, and then you get these little sparks that come off it. And they're basically like intra-cloud lightning or inter-cloud lightning, where 80% of all lightning actually happens inside the cloud. That's why you get lightning that looks like this, but you don't hear the thunder, because yes, there is thunder with it, but because the lightning strike's so small inside the cloud, generally you don't get the rumble with it, because it's just far too weak to reach the surface or the ground. And then you can see northern lights there, and then lightning flashing in the background. I've only ever seen that twice in my life, once when in the Beaver Valley, as well as this was over Lake Huron in 2017. And this is an anvil crawler. So with lightning, if you ever see it kind of crawling across the sky and you can actually see it doing so, that's what it's called. It's called an anvil crawler. And then this is a cloud to cloud lightning strike. So one storm to the other. And this is a neat type of lightning strike. This is called upward lightning. And you can see here, it kind of goes up and then across. I'll actually play it one more time for you here. It's usually triggered by by cloud to ground lightning strike. So you kind of see a flash there first, and then all of a sudden you see the upward lightning here. Now, usually this comes from high rises, radio towers, but now with more windmills in Ontario, we're actually seeing them come up from windmills as well. Naturally, they come from mountaintops, but for the most part, they come from man-made objects, and that is, for example, windmills here. So you can see the cloud to ground lightning strike off to the right, and then all these lightning strikes going back up into the sky, and they're generally each coming off a windmill there. So really neat to see that effect. There's actually one chaser in the US that caught 17 of them going up from windmills. And I'm going to show you one more time here. Here's an example, just zoomed in. So the cloud to ground lightning strikes happened off screen, and then you have all these kind of fork-shaped features going upwards from the windmills. And then there's stratiform lightning. And I remember being in my house in Markdale and seeing some tremendous lightning displays where the line is basically dissipating, but there's still a lot of charge in the upper parts of the cloud. So you get lightning that just goes all across the sky. And it just seems like it's nonstop from horizon to horizon. It may be sporadic, but when it does flash, it's quite spectacular. So we're going to look at one. I was working with Environment Canada on a project at the time. I was basically their ground confirmation, where I was to get either video or photos of it, as well as my time and coordinates of the lightning. So this is towards Niagara Falls direction. And the actual lightning strike started out over Lake Ontario, and then went towards Niagara Falls, and then back towards Hamilton. It was 67 kilometers in length. Now, the purpose of the project was to help them confirm their lightning. They could see it 3D on the models, but more importantly, it was to measure storms uptick in lightning. If a storm starts to intensify in lightning, it can mean there's hail, starting to hail buildup. It can also mean if there's wind shear parameters in the area, which can cause tornadoes, that if the lightning's picking up and there's rotation in the storm, it could mean that that's intensifying, which should help them with their warning and watches for issuing that aspect. Now, on the backside of these lines, you can also get mammatus clouds. You've maybe seen them before too. I remember looking at it from my house in Markdale at my front door and seeing these clouds often on the backside of storms. And what they are is cold, humid air sinking, and they kind of sink in these bubbles or pouches, whereas most of our air is warm, moist air rising, and it forms kind of those firm looking cauliflower clouds, the cumulus clouds, and that type of thing. So kind of neat to have those cold air sinking and also being humid at the same time, so it produces those bubble-like clouds. And last but not least, we're going to take a look at inferior mirages as well as superior mirages, and this is something you can experience over Georgian Bay. And the first one is inferior mirages. You can actually experience that just driving down your road. If you look down the road on a sunny day and it looks like there's a puddle on the road and you get there and it's gone, that is your typical inferior mirage, because the inferior mirages reflect the sky, bounces off the road, the light bounces off the road, or that refraction, and then back to you as the viewer, and it looks like a puddle, but basically it's just a reflection or a refraction of the sky. But we have a different type that's called superior mirages. And that is where it's really neat, because it can make a city look like a futuristic city. So in the next clip here, you're going to see Toronto, and the buildings are going to look like they're kind of hovering in air there. And that is because of the fact that so if you have an inferior mirage, you have the hot pavement, asphalt, really warm, and then colder air going over top of it. And what's really neat is cold air refracts light slower than warm air. So when you have a superior mirage, what happens is at this time of year, both Georgian Bay and Lake Ontario, all the Great Lakes really are really cold. So it kind of creates a bit of a bathtub effect, only it's cold water instead. So what happens is you have cold air at the surface or over the lake or bay, and then you have warm air above. Well, usually warm air passes through cold air, and that's how you get the changing in temperature. Well, in this case, the cold air is locked at the surface and it doesn't want to rise. So it just creates this boundary between the cold and the warm air, giving you kind of these really neat layers. And sometimes you can see ships. You see a regular ship and then it looks like a ship is traveling on top of it upside down. That is another thing. And I've seen it on Georgian Bay where the escarpment looks like it's longer than usual, or it's flipped upside down as well too. So it is something to keep an eye out for if you're up at Georgian Bay, especially between anywhere from March until June. It's something that you might be able to see there that just gives you something different to look at. Even at sunrise too, it can be interesting. Here it looks like a cloud in the background, but that's actually a superior mirage flipping the land upward. So again, to prove this, I'll show it because it does just look like a cloud. This is the Niagara Escarpment in the Niagara region, and we all know that there's no overhang like that, because that could be anywhere from 5 to 10 kilometers in length. So that would have just collapsed many years ago. But that layer was also over the lake at the time. So therefore, you can see the sun looks like it's in the shape of a Smartie. Well, I sped up the film and note how it's not rising. It's just kind of sliding, kind of looks like a hockey puck until finally the sun came up. Well, I was actually seeing the sun for about 1.5 to 2 minutes before it came up. And that's because of the fact of the superior mirage effect, basically the cold lake and then the sun below the horizon, but the light being bent upwards and then back to me as the viewer. So really neat in that aspect. So just something, if you're on the water there, just keep an eye out for it. You might get to see some really neat things. And I'm going to just stop it here, and well, the show is over, but I'm going to play that 1:55 seconds of sound for everyone as well too. I'll just get that queued up here, and that will kind of give you. Part of what I love about weather is the sound. So it's I always like to share this segment with everyone as well too, because it kind of gives you the feeling of it too. So there we go.
So you thinking that's a pretty solid hail core right there?
Yeah.
Yeah.
Going green.
Yeah.
They are kind of the wilder sounds of things, a few peaceful things as well too, but some of the wilder aspect. And before I forget about it too, I'll share these websites. You're welcome to type the questions into the chat, or I think we have a relatively good sized group here today where if you're comfortable, you can even ask on on camera as well too. So, but first I'll put in the websites into the chat. I see we already got a good question here already from Barb, so looking forward to answering that. And yeah, so the two websites that I used to start out with were spaceweatherlive.com and spaceweather.com. So I'll say that one more time, and like you can always check in the chat as well too. But spaceweatherlive.com and then spaceweather.com. So these websites, spaceweather.com is probably the one I would use first because they actually do written forecasts. They don't forecast for Canada, but the best way to utilize them is if you start reading about states like New York State or Maine, start seeing Michigan or Ohio, generally then that means northern lights for us too. Like we are generally, especially Ohio, we're further north than them. And the further north you are, the better the northern lights will be for you. So in that sort of case, that's just the best way to utilize that. And then if you get comfortable or more curious, what you can do is then just Google northern lights forecasting tools, and you might be able to find something that you like better as well too. But those two will get you started off nicely, and hopefully you can experience the northern lights from your area if you haven't already as well too, because I know from years of photographing them in the Grey County region, I know that you can experience some very beautiful displays. And people like to say you have to stay up late for them. Well, actually, the earliest display I had ever seen there before was 6:45 in the evening, which back then was actually 5:45 because of the fact that it was before daylight savings time shifted till after Halloween. So this was before Halloween. So it was actually 5:45. I started to see them in the twilight. So yeah, you don't necessarily have to stay up late. Some of the best displays I've seen have actually been between 8 and 10 p.m. and that, or just right after twilight. So that's another thing. You don't have to be a night owl to experience them. And so I'll answer this question from Barb here. And how do you keep your camera equipment dry in weather like that? Not to mention you getting blown away yourself. All right, so I'll answer there's kind of two parts to that one. But yeah, basically our camera gear, I'm the navigator and radar operator of the storm. So what my job is to do is when we're chasing a thunderstorm is to work around it. So I'm to find the dry slots. And so I use both a radar and GPS to kind of do both at the same time. And that really allows me to work in such a way that I'm not, there's some nights where, for example, one night we chased storms for 6 hours and we only saw 5 minutes of rain. So that's, having a great driver that can just focus on that, then having a navigator and radar operator, as well as my friend Kyle Robertson, who's also a storm chaser, observing things. It really allows us to do 3 different jobs without crossing over, and that really allows us to put us into position. So sometimes we do have a shower come in on us, so we'll either run out and grab all our gear and get it into the vehicle, or just let it pass overhead and then get on the back side of it too. So, but most of the time I'm working us generally in between the showers and just kind of keep going from that point. As for not getting blown away, kind of the same thing. Basically, on radar, we can see precipitation, but I can also get what's called velocities on radar as well. So that'll show me both rotation as well as straight line winds. I know, for example, the windstorm or the thunderstorm line that came through last October 23rd, it was one that had, you could see the whole edge of radar showing that the winds were quite strong on the front of it, anywhere from 70 to 90 kilometers an hour. So I knew the straight line winds in that area were going to be strong as well. So we can see that all on radar. What was tricky years past was the fact that Canadian radar was sometimes as much as 10 to 15 minutes behind. So what I had to do in my head was animate where I felt the storm would be at that time. So I would use navigation and then kind of place where I felt the storm would be at a certain point. And most of the time that worked, but there was some times where radar was really far behind, and that was a little bit tricky to do as well. And we have a question from Marianne here. All of the lightning you showed is what I always called fork lightning. There is also sheet lightning. Why do why do we sometimes get sheets and other times forks? So yeah, most of the lightning we see is sheet lightning. It's about 80% of all lightning. And sometimes when it comes to sheet lightning, it can actually be a fork. It's just behind a bunch of rain. So we just see it as a big bright sheet. Another reason is the fact that there's, like I said, 80% of all lightning is inside the cloud. So therefore we see a flash, but there's nothing that came down to the surface as well. So that's another reason why we'll see sheet lightning. And another thing that we can have also is storms in the distance. So you see the whole kind of thunderhead light up, and it just looks like a sheet that highlights the cloud. So that's another thing too. But generally that's all because of the fact that, like I said, 80% of lightning is inside the cloud. So excellent question there, Marianne.
If I may use the microphone and encourage everybody who may still have a question, just go unmute yourself and speak away. We're
Absolutely.
small enough a group that we we don't, not much of a risk of talking on top of each other.
That's
but
right.
Since I've got the mic on, let me ask a question.
Sure.
So you must get up in all sorts of hours, middle of the night, crack of dawn, and how often when you go for a shoot do you come home with a glamour shot, and how often not?
Right, yes. So it's gotten to the point now where I basically wake up and if I know the temperature as well as the time of year, what system's moving in from the day before, I can wake up and I know what type of weather phenomena to expect. And so that's made a big difference on going out, and to the point where I can actually time it with errands. So if I have to go grocery shopping, I will time that with the system coming in and get the two to get, not necessarily put the grocery store in the foreground, but I can go to the lake, get what I need, and then go do the grocery shopping after. So it's kind of neat in that aspect. But yeah, I'd say generally, the more I learned over time, it became more, I can generally get that spectacular shot every time I go out now. Whereas when I first started, not as much knowledge in weather or timing and that to it, it was more sporadic then. So 20 years later, it's hard to think of it so differently now because it almost became automatic due to the fact that I've probably done photography at every second of the day has probably been covered at some point in my 20-year career. So it's just kind of years of experience and then just that continuous study of weather. And the sky, I always treat it as if it's my teacher and that. So it's always got interesting things in it generally. It's just that timing it to get the spectacular things is kind of an art form in itself too. So yeah, thanks for asking that, Martin.
I have a question for you.
Yes.
Did you go to school to learn meteorology and all of that stuff, or are you self-taught?
Yeah, so I am self-taught, and one of the neat things about it was the fact that it started from a very early age. I was born in Guelph. I moved to Markdale at the age of 4 years of age, and lightning struck my house in Markdale. I was at that 2 to 3 year age bracket where I was, had to ask why, what, when, every question you could think of. And apparently with each answer my mom gave me, my face got bigger and bigger, and that with excitement, and that because, wow, lightning could knock out the power to our house. And so after that, there was the grade 3 book it program, which when I went to school in Beavercrest was a fantastic one for learning how to read. So while others were reading Bear Steam Bear books and Clifford the Dog, I was reading about tornadoes, mesocyclones, hurricanes, rainbows, etc. And so after that point, I just kind of kept digging into it deeper. I use a lot of government websites. I use a lot of private studies, and I like to cross-reference. So if I see something that is new in the field of research, I look for other scientists that agree with it as well too. And it's really allowed me to just kind of just keep digging deeper myself. And I do use all the same weather models that the meteorologists use as well too. So it's just been something that I've just continued to try to dig as deep as I can personally to always be the best that I can be.
Wow. I thought the photos were just incredible.
Oh, thank you, Carolyn. Thank you.
Your presentation was excellent. So I was very impressed. Thank you very much.
Thank you very much too.
Elspeth, you raised your hand?
Yes, I did. I was caught last year in that 24th of October storm, which actually it helped, but it didn't mean any good. I was driving near Collingwood, and they have like the way, where they have Amber Alert. Who
Yes.
sends that out? And it was sent out. However, you have so much traffic, you can't go and avoid the whole thing. So of course, I was caught in that hailstorm, and thousands of dollars, of course, hail damage. But
Yeah.
even so that we had that alert, I mean, it was maybe a help for some people, but if you are in Collingwood, there's no way that you can escape it unless you have some brilliant ideas.
Yes. Yeah, that is the tricky part. I mean, when you're on the road, you're always, kind of at the mercy of the weather at that point. And it's Environment Canada, so that does issue that alert. And so they have to be also a little ahead of things as well to make it more productive for people. And I know that they accidentally, I think it was about a month or so ago, I was doing a presentation, oddly enough, and I was told that there was a tornado warning in Chatham. And I was like, oh, the low pressure system got here a day early. And so anyways, what had happened is they were testing out though, and they accidentally issued a tornado warning all the way from London right down to Windsor on a perfectly blue sky sunny day. So there's still some things they're working out in that, and I hope that they do become a little bit earlier with their warning, because it will help people, especially when they're traveling, as well as people that are at home, because we all know that earlier the better, and that gives you a chance to adapt to the situation or do what you need to get to safety.
And also a little bit of the time frame too. Nothing was said about, like you have about 10 minutes to go to safety, because if I would have known that, maybe I would have somehow turned somewhere into a driveway, or anyway, it's very, very difficult. The insurance, of course, had a good day. They had tons of cars to fix, so they thought, hooray for us. Okay, so I mean, it's fantastic, those pictures you said, and it's living in Thornbury, and I'm in the 3rd floor. I have fantastic view for a huge sky, and
Excellent.
so I take a lot of pictures myself just from up here, but nothing like yours.
Oh, that's okay. My pleasure. And it's all about capturing it for yourself and those memories. So no matter what the photo looks like in the end, it can help trigger the memory. That's always been my rule. Get the photo first, and then I can worry about composing it or whatever I need to do after that point. But just a little bit more on the warning aspect. One of the things that I wish they would do, and I'm hoping they will do, is right now it's very regional. It's very large. The warnings can be, let's say, for example, all of Simcoe County or all of Grey County, or half of Grey and half north and south. What I'm hoping they will do is turn it more into like what the US does. And that is, when a thunderstorm is coming in, they can actually mention the towns that are in line for that storm and give a time frame. That is what I'm really actually hoping, that they can get to that type of effect, because right now there's a lot of people that are criticizing it, and rightfully so, in the fact that they can be on the sunny end of the tornado warning and not have, well, why do I have a warning? And that, whereas the other area that's getting it, it's starting to kind of make people go, well, oh yeah, I've had one of those warnings before, and then they kind of go, oh, it's not going to do it this time, and that could be the time that it does it. So there are definitely some things that I do believe they need to work out, and I think they are. It's just going to take a bit more time.
There was one comment by Maureen. If it's okay with you, David, I will provide her with contact information so she can send photos to you.
Oh, perfect. Thank you. Yes, I wasn't up there that day, so I would love to see some photos from that. Thank you.
Awesome. All right. Brenda, if I can pass the baton back to you to give our thanks to David.
Absolutely. And it's my pleasure, David, to say thank you to you. It was an amazing presentation this afternoon. I now know a little bit more about weather. I can't say I picked it all up, but now the pretty colors in the sky will have some meaning. So I really appreciate that. And I'm sure that everybody that sat in on it today has also appreciated your experience and knowledge. So thank you. Thank you so very much. And as is the custom of Probus, we have an honorarium for you. And so that will be sent on to you.
Okay, well, thank you so much, Brenda. You were a joy to work with and communicate with. And then once I knew Martin was going to be a part of this again too, I was just like, oh, it's like two homecomings, because I like to work with people I've worked with in the past, as well as the fact of I was coming home to the Beaver Valley, and one of the most beautiful places in the world in my eyes. So it was great to be back and talking to everyone and presenting about home. So thank you.